Okay, so guys and girls, few things. So we are, cruising along. Obviously today is Halloween, so happy Halloween. Um, I'm especially excited for a week from tomorrow to be done with because I have already submitted my voting, and I don't want any more political calls. I don't want to watch any political cartoons or commercials or anything like that. I'm done. So I think once like you submit your ballot, like there should be like this electronic scan thing going. Oh, he's in. So, huh? There was 22 people running for president. I will just say of those 22, there might be a few that might not be eligible, but I'm not going to tell you which few. I just couldn't believe it. There was 22 people on the ballot to vote for president. You know, there was parties I had never heard of. What's that?
I hate Trump.
Oh well, you
So
know.
freaking racist.
Well,
Wrong. Really?
I didn't hear what you said.
he's just he's getting caught up in the propaganda, unfortunately. So you'll learn statistics one day, and you'll realize that a lot of the stuff that's ever swayed on TV is propaganda, and it's not true. I would definitely say yes. I would say it is the best math class to take because statistics is used to sway people's opinions so easily, and it's so poorly done. So the thing is, like, so here's just a very basic statistics problem for you. Let's say you have a quarter, and you go to flip the coin. You flip the coin 20 times, and let's say 18 of those times you got heads. Do you think it's a fair coin or not? And a lot of people would say, no, it's not a fair coin. No, it is a fair coin. The coin doesn't remember what it flipped last. So any sequence of events, but unfortunately people don't understand how statistics works. So they want to say, oh, they're doing it wrong if it's this or that way. You guys have all been a part of a huge statistics experiment just because of when you're in education. And we had something called No Child Left Behind that took place, which was a disaster in public education, in my opinion, because it took away from so many programs that were offered for kids in a negative way. And it was so rated on just raw data and making knee-jerk reactions to what the data, they thought the data said. And the thing is, you can't look at data and make a valid argument against just data, because you have to run specific tests on data to ensure that it is valid or not. It'd be like me surveying this class saying, what do you guys like for lunch? And then what this class says they like for lunch, if I then apply it to the rest of the United States or the rest of the world, that's pretty inaccurate as far as representing data. But unfortunately, that's a lot of what people use statistics for, and it's horribly done. So the more you know about statistics, the better you will go through life. So when my mind turns off to people is when I start hearing, 15% of people, forget it. I'm not even listening.
Wait, is that the class you need to take in college?
I would. I definitely would. I'm telling you, it will make you a much better thinker towards life. So I very much encourage it. Unfortunately, there's too many people out there that really aren't very intelligent who find that if you start throwing numbers at something, it makes them sound smart, and anybody who understands mathematics will say, I don't buy it. I even saw it here in this district. I was on a committee. What No Child Left Behind basically does is let's break people down into the most tiniest of subcategories possibly imaginable, and then look at those subcategories to determine if we are actually doing well as a school or not. And Cherry Creek High School does very well. But there was one subcategory. So here was the subcategory. Ready? See if you can follow me. Native American, still with me? So there's a cat, break somebody into a subcategory. Male, there's another subcategory. That were on free and reduced lunch, that's another subcategory. So now we're 3 subcategories in on this. who's came from a broken home. Now, fourth subcategory was not college ready at Cherry Creek High School. We had 100% of Native American males on free and reduced lunch that came from a broken home that were not college ready. 100%. Sounds pretty crappy, doesn't it? It's one student in the school that fell into that subcategory. But of course, the district, they look at this, go, well, look at this, you have 100% of these people that aren't. It's one person. Yeah, but it's 100%. It's one person. So that's a real specific way of how they will make it look like the sky is falling, and God forbid somebody under a certain socioeconomic, religious, ethnic, whatever category you want to try and put people into, it gets pretty pathetic. And you sit there and you look at these guys with No Child Left Behind, going, that means nothing. But no, it really does. It means nothing. And so they want to get into the yaha. And so all we have to say as statisticians is, what was your hypothesis and did you test the null? What is that? That didn't take place. You cannot validate your data at all. We have a hypothesis. What is it? Well, just because I don't know, it doesn't mean we don't have one. And you are running the State Department of Education in the state? I am. Good. See what kind of cynic I am sometimes? So, let's get off my soapbox. So anyhow, we have this week, next week, the following week. We have 3 full weeks and then 2 days, and then we are on Thanksgiving. I mean, and that's going to cook pretty quickly.
And then 3 weeks after that, we have
and then is it 3 weeks after that? And then after Thanksgiving, we come back. We have a week. Wow. We have 2 weeks after break, and then we go into final exams that 3rd week.
Really?
Yeah, and then you have winter break. And then, the most important date that I have on my calendar as far as that's coming up is Rogue One, Star Wars, coming out the 16th of December. So I just needed to point that out. So mark
is the 19th.
mark your calendars.
Shut up, Joseph.
So those are just a few things on our agenda. Sound good? All right, let me pass. We have some notes.
Wait, do we have another test coming up?
Take a look at the board. So you're learning the same thing today and tomorrow and working with that. And then we're going to do something on Schoology after that. Six. 1, 2, 3.
No, shut up. No.
3. All right. One of the Stevens, can one of you catch the lights for me, please? All right, I gotta just go by what's on here. Let's see. Tools. That'll work. All right. So our first problem on here says y equals, what is that, 1/2 x minus 3? So a few things to warm up on this. This is in slope-intercept form because y equals, correct? So this will tell us where it crosses the y-axis. Where does this appear that it crosses the y-axis?
-3.
Y-axis crosses at -3. So how is that as a point?
0, -2.
0, -3. And it's important that you start realizing that's a point. It'll help you a lot more if you continue to realize that's a point. Through math. So that you're indeed correct if I say what's the y-intercept and you give me the 1 point or the dot or whatever. So let's plot this. 0, -3. So 0, -3 is down here as a point. Agree? Anything about what we've just done that is like, oh shoot, it's been like 10 whole days. Then how do I find a second point in this situation?
Up 1
Rise
over 2.
over run.
Use
So
the
what
slope.
is this called?
Rise over run. Slope.
Rise over run, slope. Okay, so the slope. Now here's a straight question. See if you remember from 10, 12 days ago. Is the slope a point?
No.
No, it's a map to find another point. So you have to have one point identified to find another point. So from this point, I'm going to go up 1, and I'm going to go over 2. And from there, connect our dots, and we have our equation. Correct? Pretty cakewalk. All right. Can I move off this screen?
Yes.
All right, next one. Let's do this again. Math, bless you. Graph, Cartesian. And we have 3x
-6y.
-6y equals what?
6.
6? Does anybody remember what form this is in? It's not slope-intercept, I'll tell you that. Go ahead. It is called the cover method. I like it. What form is it? Standard form. Good. So this is in standard form. We're going to use the cover method. The cover method means we're going to find where it crosses the x and where it crosses the y-axis. Okay? So what that basically means is I'm going to plug a 0 in, get a that, and I'm going to plug a 0 in there. So this is an x value, right? And that's a y value. And this is also an x and a y value. Agree?
Yes.
All right, so let's do the cover method. Let's do the cover method. I'm going to cover up the x because I'm plugging 0 in. So I get -6y equals 6. So what's y equal to?
-1.
-1. So 0, -1. It's this point right here. Agree? Now, what am I going to cover on this one?
The y.
The y, because I'm plugging 0 in. That becomes 0. So I get 3x equals 6. So what's x equal to?
2.
2. So I get 2, 0. So the cover method finds us the 2 points in this case. We could find the slope pretty easily. The slope is up 1, right 2. So the slope is 1/2. We want to do that. Because remember, the slope is just a map from point to point.
Wait, is this the same equation as the one before?
I don't know.
It's like, isn't the slope the same slope?
This one was down. This looks like it crossed at -3. This one crossed at -1. It's a similar type of line. It could be the exact same slope, just by coincidence. Feel okay so far?
I just had another question.
Mm-hmm.
What's the other equation other than the slope intercept and the standard?
Point slope. That's the y minus y1 equals m parentheses x minus x1. All right, so let's think about how we do this. If we had this, and we've solved this before a while back. So item 1, how many variables, which is a letter, do we have in this problem? 1. Okay, so this is just going to fall onto a number line. So we want to know where to plot this. So how would I go about starting to solve this type of problem?
-6.
Subtract 6, I like it. So I'm going to cancel. So I get 2x is greater than 6. Then I'm going to divide each side by 2. Cancel, x is greater than 3. Open or close dot?
Open.
Open. And am I going right or left?
Right.
Going to the right. Well, value's bigger. And that's what that looks like. Why is it an open dot? because we don't include the endpoint. It's not equal to it. It's just greater than it. So as you go down right below, it says, what about if you had 2x plus 6y is greater than 12? Okay, it's still going to be a picture, and we're eventually going to get to it, but we're not going to get to that yet. It'll be on the back side. So take a look at that. It says 2x plus 6y is greater than 12. So I have x and y now. If I have x and y, that means I need to use the xy axis or the Cartesian plane or the coordinate system. Okay, it can graph. So on this type of problem, when we shade one way or the other, once we start getting to the next thing, we're going to start realizing a few things. Linear equations, linear inequalities are linear equations, but they have an inequality sign. So they'll cut our graph into two parts if we just graph one line. You'll have a top of it, a bottom of it, a left or a right, side to a side, front to a back, depending on how your graph is. Okay? So how would we go about, down there at the very bottom, is this a solution to this? And how would we check if it was?
Put the 1 in for the y because it's in for the y.
Okay, put the 1 in for the y and do what else?
Multiply 6 by 1 and then take that number and subtract it from 12.
Is this an x and a y value?
Yes.
Yes. So can I plug my x value in here and my y value in here? Everyone with me? So this is like a test point. What could happen here? We could get something that's true and something that's false. Okay, so I have 2 times 0 plus 6 times 1. Is that greater than 12? And I heard that it's false. I think you're right. 2 times 0 is 0 plus 6 is greater than 12. Is 6 greater than 12? No, this is false. So is 0, 1 a solution to this problem? No, it created a false situation. If it created a true situation, then it would be a solution to the problem. Yeah?
I have a number that's, or a point that's a solution.
Oh, you picked another point that worked? Cool. I like it. Yeah, there's an infinite amount of points that will actually work. So I'm on the back side of our page. Let me pull up that graph again. Math, graph, Cartesian. Okay, so we have 2x plus 6y is greater than 12. Does this look kind of like the cover-up method would work, but we have an inequality sign?
Yes.
Feel okay about that? Does that make sense? So this is in standard form, but we have an inequality sign. So we have a greater than or less than sign, right? So I think the cover method, so let's take a look. This one will work with the cover method. I'm going to plug 0 in, and I'm going to plug 0 in here. And we're going to use the cover method just like we normally would. Okay, I'm just going to try and find 2 points for right now. Make sense? Okay, so if I have this is a x or a y value. X or y? X. So this gets covered. 6y, 6 times what gives me 12? 2. So 0, 2. And then this is a y value, so I'm going to plug it in there. So 2 times what gives me 12? 6. Does everybody feel comfortable about that?
Yes.
Now, if it was an equal sign, I'd just draw a line between the two and put an arrow at both ends. Correct? But it's got an inequality sign. Is there an equal part to this? Is it greater than and equal to, or just greater than?
Greater than.
Greater than. So being I don't have the line underneath, that means our line has to be dotted. Can everyone recognize I have a dotted line? Does it connect those two dots? Okay, now we're almost done. Almost done. So you remember when we just had one letter, we just had to see if something was, shade one way or the other. Now I have to shade either up here or down here. So let me do that kind of, let's do this. So this is going to work first. So we either have to shade all up here. So it was a magic pen, so. Yep, there won't I? Or I need to shade down here. Okay, so we have to figure out where do we want to shade. Do we want to shade above or do we want to shade below? What do you think?
Above.
So we have one above, so we shade above. Maybe? Or do we shade below? What do you guys think? Guys and girls, someone said above. And that might be right, I don't know. But should we shade above or should we shade below? How could we figure out? What exists all up here and also down here?
Numbers.
Numbers. What kind of numbers?
Negatives and positives.
Negatives and positives. And are those negatives and positives coming together as points? Is there a whole bunch of points that lie down here?
Yes.
Are there a whole bunch of points that lie up here?
Yes.
So we have to pick a point. Okay? So, I don't know, we could pick a point above or we could pick a point below. If we pick a point above and it's true, that means all the points above will be shaded. If we pick a point below that's true, we'll shade below. If we pick a point above and we test it and it's false, that means all the points above are false, so shade the other side of the line. If we pick a point below and it's false, all the points below the line will be false, so shade the other side of the line. So I have this side up here, I have this side down here. Agree? Is there a point that looks like a really good, easy point to pick that does not lie on the line, either above or below? You decide. And if so, shout it out. What do you think?
1 and 3.
1, comma 3. Looks like it could, or 1, comma 3 right there?
Yeah.
Okay. Stephen, is that above the line or below the line in your thought?
Above.
Above? Agree?
Yes.
Okay, is there a point that might be below that looks like a good, easy point to pick?
1, negative 1, negative 3.
Negative 1, negative 3, okay. Is there another point above? 3, 3. Is there another point below?
Negative 3.
Negative 1, 1.
Negative 1, 1. What about 0, 0?
Below the line.
That's on the
Is 0, 0 below the line? Does everyone feel that's okay? Is 0, 0 pretty easy to plug in?
Yeah.
Yeah. Now, I can plug any of those in, but I'm going to take that 0, 0, and we're going to call 0, 0 our test point right now. And you're absolutely correct on all the others. They do indeed work. But 0, 0 is a really easy thing to plug in. Is 0, 0 above or below our drawn dotted line? Below. Does everyone feel comfortable with that? So our test point happens to be below. And we're looking to see if it gives us a true or a false answer. So we want to know, is it true or is it false? So I'm going to take my x value and my y value, and we're plugging it back in the original. 2 times x, which is 2 times 0 plus 6 times 0, is greater than 12. 2 times 0 is 0. 6 times 0 is 0. Is 0 greater than 12?
No.
Is that false? Is this false? This is false? Agree?
Yes.
So that means that I need to shade the region that is not where 0, 0 is. 0, 0 is below my graph. Where should I shade?
Above.
Above. So we'll shade above. Oh, let's use the old crayon. So we're going to shade up here. You guys want to know who the frustrating kid is? You'll recognize this during the test.
Did we just hear that while we're taking a test?
That's not
Rom, I feel like that's gonna be you.
Yeah, Rom.
And then you hear, and then they're that kid whose eraser has just dropped a smidge below the metal part on their pencil, and they start erasing. And you're like, and everyone's going, ah! Can I have another paper? No. But I don't have an eraser that works. No. So, which kid are you? Are you the one that needs to fill this entire thing in? Or can you just shade it and call it good, saying, you know what, it's above here? Because I totally get that, but, sometimes other people have beautiful minds as well, and they have to color everything in. And I have noticed, and maybe this is wrong, but in 21 years of teaching, the kid who sits there and shades nonstop is the kid that, I chose the wrong region. And it's not like he chose the wrong region after going scribble, scribble, scribble. It's like 15 minutes worth of art. Grayscales from 0 to 1 billion as far as on their paper goes. And you're just like, dude. And you guys are all going to chuckle because you're going to see something. You're going to hear that during the test. And then you're going to I'll be sitting over there. I shaded the wrong region. Took you 15 minutes to figure that out of coloring? Yeah. Sorry. Maybe just write me a note.
It's gonna end up being me.
Again, beautiful minds are beautiful minds. There's nothing wrong with a beautiful mind, so I'm not going to take that away.
Unless it's wrong.
So let's see. The things that they had, graph the equation, we did. Decide if it's solid or dotted, we did. Test point on either side of the line. We found 5 of them. We only used 1 of them. And then shade where the point works. And the answer is basically your picture. Okay, yeah.
So, if the sign's like a greater.
Oh, we'll get there. We'll get there.
Do we need to show all that work that you showed?
No, I was just trying to walk through the whole thing.
Like at least 10.
Right. He does. He's got a beautiful mind, though. You know that.
Shut up. At least I have one, Liam.
Ooh, burn! All right.
What?
Okay, does this appear to be in point-slope form, standard form, or slope-intercept form? Slope-intercept form. Does that make sense? Okay. So this appears to be slope-intercept form. So where is my y-intercept?
It is -5.
So 0, -5?
Yep.
Agree?
Yes.
Is that all right?
Yes.
What is my slope?
2.
That's my slope, 2/1. So from here, I'm going to go up 2, right 1. Solid or dotted? What do you think?
Solid.
Solid. Why is this one solid and the last one was dotted? This was dotted.
Because it has an equal part to it.
Yeah, we have this little sign right there. Means this has got to be a solid line. Okay, so I'm going to connect my dots with a solid line. So I have kind of over to the left and kind of over to the right. Would that verbiage work on test points? Where does a excuse me, a good test point appear to be?
0, 0.
0, 0. Okay, you know why 0, 0 works so well? It's because it doesn't interfere with excuse me, our graph that much. So in your opinion, 0, 0, we'll call on test point 0, 0. Does 0, 0 appear to be on the left or the right?
Left.
Left. Now some of you might be like, oh, but it is above it. Some of you might see that as above the graph versus below. But 0, 0 is definitely on one side of the graph. Agree?
Yes.
So I'm going to take 0, 0. I'm going to plug 0, 0 in. And we want to see if it gives me true or false. Agree? And if it's true, we shade that side. If it's false, we shade the other side. So 0, 0 is our test point. That's an x and y value. So I'm going to plug that in. I have 0 is less than or equal to, that used to be a y, but now it's a 0. It's equal to 2 times 0 minus 5. Is 0 less than or equal to 0 minus 5? Is 0 less than or equal to -5? No. 0 is a bigger number than -5, correct? So this gives me a false. So I'm going to shade the other side. I'm going to shade over here. And no, I'm not going to be the kid that colors in every little grid pixel. Sorry.
Are you like gonna take off points if like someone does that?
Mr. Sturb only got done with one problem. Why? Well, I wanted to color it in nice and neat.
Okay. Hey, but some people their minds work that way, and that's a beautiful thing. There's nothing wrong with that. Okay, can I go to the next problem? Number 2. Can I clear off this screen?
Yes.
Okay, why don't you try number 2? Just get a graph. It looks like it's going to work with the cover method, and just by looking at the equation, is it solid or dotted?
Dotted.
No, got it.
Dotted. Got it? So I'm gonna try mine real quick. Once you have your dotted line, take a look at mine and make sure yours matches mine. I might have a different color, but that's okay.
Oh, dang it.
Did you color the wrong side?
No, I did the wrong problem.
God, wrong.
That's what you're testing.
You did the wrong.
Zero is greater than
Dang
12.
it. What? Did you do the wrong? No, I did the wrong problem.
What do you think? Do you agree?
I agree.
Hey, if this is cover method, what's that called? What kind of form?
Standard.
Standard form. Okay. Huh. Ooh, number 3 seems like it's a special case. What's missing on number 3? It's a vertical line. Good. What am I missing? What letter am I missing? I'm missing the y value. So I have x is less than or equal to 5, and okay. So this is a vertical line. So is it solid or dotted?
Solid. No, it's
Solid. And it's a vertical line right here. So I have a test point that would work. I mean, this test point does work, but what's weird about the test point? What's wrong with the test point versus our equation?
Well, X.
What about it?
It doesn't
Yeah,
have a slope.
this has an x and a y, but this only has an x.
Undefined.
So, no, it is an undefined line. You're absolutely right. It's an undefined slope. But what we have to realize is, in this case, because this was just x equals, we're only going to use this. That's our test point right there. I don't worry about the y component because it doesn't exist for us. So is 0 less than or equal to 5? That's true. So that means I shade all over here. What do you think?
Doable.
I like it. Does anyone want to take a shot at number 4? Is that a special case as well?
Yeah.
It's a horizontal.
It's a horizontal line. It's missing the x. Good. Okay. So can I move off this screen?
Oh, but it's dotted.
Oh, it's dotted? Why is it dotted?
No equal component.
Yeah. So this is a dotted line because that doesn't have the equal. And this is horizontal dotted. Is that okay?
Yep.
And again, our test point's kind of weird in this case at 0, 0. Which part am I ignoring on this?
The X.
I'm ignoring the X. So in this case, I'm looking right here. So I'm going to plug that in as 0 greater than 3. That's false. So where do I shade? Huh? The top part. Yeah. 0's on bottom gives me false, so you shade the opposite region.
So if one.
So everything down here, if I would have picked any of these points down here, it would give me false. Everything above is going to be true. Like if I were to pick this point, 0, 6, 0, 6, and my y component 6 is greater than 3, totally works.
Wait, Mr. Stroh.
Yo.
So
As he
for
did this simple thing shading it, he shaded the wrong region.
so like for these kind of theories that, or I guess rules that if one point below the line doesn't work,
Then they all.
how is that proven correct?
So you would actually use something called the converse to that, which means find a point below that is true.
So until they find it, it's not.
Right.
It's not falsified.
I mean, because there's infinite points, right? So this is the theory. You didn't just get lucky and find the one value that was the false or the true. It's going to apply to all them all unless we can prove it different.
So this is a thing that's not falsified.
Huh?
So this is a thing that cannot be proven.
At this, it can't be proven false at this point.
Okay.
All right. Number 5. Number 5. We're ready. Last one, isn't it?
It's cover method.
So it is cover method. I agree with you. The cover method is known as what? Standard form. Good.
Weird.
All right. So solid or dotted?
Dotted.
Dotted. Okay.
Test point equals
And
0.
cover method. So cover this. Y is what? 3. Cover this. Y x's.
3.
Okay. So 0, 3 is here. 3, 0 is here. Dotted. Does our favorite test point work here? Yeah, it's not on the graph. So 0, 0 is indeed our test point. Okay, so plug 0, 0 in. 0 plus 0 is greater than 3. Is 0 greater than 3? That's false. So where do I shade? The other side. So that's kind of like on the bottom or the left side. So I could shade the top or the right. And that's it.
I feel very comfortable.
You feel comfortable with this? Sweet. I had quite a few days to rest up and prepare for this lesson. So that's the best you're going to get out of me for the rest of the semester. All right. Your homework assignment, your homework is worksheet number 11. That which is page 95, 96. You guys got this? I understand. I understand.